very much. I want to thank Taylor again. So next up we've got Coad. So Will is going to talk today about the contribution and performance of white clover, Trifolium repens, in Tasmanian dairy systems.
Thank you, Beth. So yes, I'm Will Coad and I assessed white clover in Tasmanian dairy pastures. Firstly, I'd like to start with the Tasmanian dairy industry. In Tasmania, there are currently 412 dairy farms, which are situated predominantly in the north of the state. And last milking season, they contributed 913 million litres of milk. And this equates to $429 million in farm gate value, or 40% of the total farm gate value for Tasmania. In addition, due to Tasmania's temperate climate, dairy production systems in the state are primarily pasture-based and include common species of perennial ryegrass and white clover. White clover is a perennial legume and has a stoloniferous growth habit, meaning that it proliferates from stolons and is included in many pastures due to its high protein and digestibility. It also possesses a symbiotic relationship with rhizobia in the soil, where atmospheric nitrogen is extracted and stored in root nodules in the form of ammonia, which can then be used by plants, including white clover. And then upon plant death or nodular detachment, this nitrogen is then returned to the soil pool, where it can be used by other plants, including the grasses. Moving into justification of my research, I reviewed Belinda Hackney's paper, who assessed legume composition across New South Wales on 225 farms. And I also reviewed some papers that assessed legume composition in dairy farms across Victoria and New Zealand, and found that there was a significantly low legume composition in these pastures. I also understood that there was an association between dairy systems and high nitrogen fertiliser use, and that I also realised that there's a high importance of dairy in Tasmania based on the figures before. So I then developed these research questions to determine the percentage of white clover in Tasmanian dairy pastures and the nodulation score of these plants in the pasture. I also wanted to assess the key soil characteristics and management practices that also affected white clover performance. To assess these questions, I had to develop a methodology, and this involved surveying 22 farms across the state, with 5 farms from the south and 5 farms from the northeast, 6 from the north and 6 from the northwest. And within these farms, I sampled 2 paddocks, which were given a high or low clover rating based on white clover composition by the farm owner or manager. And within each paddock, I took 30 soil cores, 15 white clover plant specimens, 5 biomass samples, and 5 botanical composition measurements, evenly across a zigzag pattern throughout the paddocks. With these samples, I then returned to the lab and assessed botanical composition using dry weight. I also assessed plant characteristics, including shoot and root weight and length, and soil characteristics, including pH and electrical conductivity, texture, as well as cation exchange capacity, macro and micronutrients, which were assessed via an outsourced soil test. I also assessed nodulation using this scorecard developed by Howison and Dilworth, who give nodulation scores from 0 to 8 based on the abundance and colour of the nodules on the root system, and this can be applied to a range of legumes and other pulse crops. And then the second part of my methodology included a survey with 10 farmers from the 22 farms, where I asked them a range of questions regarding the importance of clover and a series of management practices that might affect white clover composition, including paddock history, fertiliser and irrigation use, pest and disease management, and animal husbandry management practices. However, due to time constraints today, I won't be talking about this part of my study. So firstly, my first set of results here assess the white clover composition across the 22 farms, and this was done using ANOVA. And I found that there was significant difference across the farms. However, there was no significant difference between the 4 regions and high and low paddocks. I also found that the mean white clover composition in dairy farms was approximately 5.4%, and this ranged from 7.7 in the northwest and to 3.1 in the northeast. This composition of 5.4% is consistent with other studies which were conducted in New Zealand and Victoria, who found that on average white clover consisted of approximately 9% within the pastures, and that in the same pastures white clover rarely exceeded 20%. And this is well below the desired content of white clover in dairy pastures of 20 to 30%, which is required for maximum pasture productivity and to achieve animal health benefits. And this is also significantly lower than the composition found in Belinda Hackney's paper, who found that between 40 and 50% pastures in dry land and fixed grazing systems were legumes. Additionally, I looked at the distribution of nodule scores across the 4 regions, and using ANOVA I also found that across regions, farms and high and low paddocks there was no significant difference. I did however find that the mean nodule score for the state as a whole was 2.6 and ranged from 0 to 5. Additionally, I also found that 76% of these white clover plants that I collected had a nodule score of 3 or less, and therefore were inadequately nodulated. This is also consistent with Belinda's paper, who found that up to 90% of white clover plants were inadequately nodulated across New South Wales, resulting in a poor nitrogen contribution to the total soil pool. I then assessed the soil characteristics. Here I found that across the paddocks, 90% had a pH of greater than 6. This is a promising sign for dairy production systems in Tasmania, as pH between 6 and 7 is desirable for both white clover performance and rhizobial function. I also found that electrical conductivity and cation exchange capacity showed minimal variation across the 4 regions. And finally, I found that soil nutrients, including carbon, nitrogen, phosphorus and potassium, were highest in the northwest and northeast. And then assessing phosphorus and potassium, I also found that they were at non-restricting concentrations. Phosphorus was measured at 31 milligrams per kilogram of soil. The optimum concentration for this nutrient is 29 milligrams per kilogram of soil, and therefore it's at an optimum level. Additionally, I found that potassium was measured at 298 milligrams per kilogram of soil. The desired concentration for white clover function is between 150 and 180 milligrams per kilogram of soil. The observed concentration, however, is found to have no significant effect on clover function, as they only use potassium as they need it. I then compared plant characteristics with soil characteristics and found that soil nitrate and ammonia had a significant negative relationship with nodule score. This is largely due to the inhibitory effect of nitrate on the enzymes known as nitrogenase within the root-bound nodules. Nitrate was measured at a concentration of 17.65 milligrams per kilogram of soil, whereas nitrate becomes inhibitive beyond the concentration of 10 milligrams per kilogram of soil, so that's unsurprising there. I also found that total soil nitrogen had a significant negative relationship with the composition of white clover, and this is largely due to the preferential growth of ryegrass over white clover in situations where nitrogen is unlimiting. I also found that pH had a significant positive relationship with both nodule frequency and shoot biomass, and this is largely due to nutrient availability in the pHs between 6 and 7. I also found that phosphorus and potassium had a significant positive relationship with nodule score, and this is largely due to phosphorus and potassium being related to improved communication between the legume and the rhizobia within the soil. So to summarise my findings, I found that the amount of white clover within Tasmanian dairy farms is well below the desired composition of 20 to 30%. Nodulation of white clover in Tasmanian dairy farms is well below adequate, indicated by the state nodule score of 2.6, and total soil nitrogen, nitrate and ammonia are indicated as having the greatest effect on poor legume nodulation and composition. So my recommendations to Tasmanian dairy producers would be to aim to increase white clover composition in their pastures, and this can be completed by more frequent assessment of the white clover in their pastures, as well as regular soil testing to ensure nutrients, including phosphorus and potassium, remain at optimum levels. I would also suggest that the reduction of nitrogen-based fertilisers would improve the contribution of nitrogen in the soil in dairy pastures through fixation, and a reduction of nitrogen fertilisers would also improve the productivity and financial returns to farmers via milk production, as well as reducing the costs of nitrogen-based fertilisers. There were some complications and limitations to my study. Obviously, the biggest one was COVID-19, which restricted travel. The other issues were sample size. I only sampled 22 farms out of 412 across the state, so therefore it's a relatively small sample size. The time of year and the time since last grazing can also influence the amount of white clover present in a pasture at any given time. And the bulking of my soil samples gave an overview of the soil characteristics for a paddock as a whole, rather than taking soil samples from the rhizosphere of specific white clover plants that I assessed. So stemming from my research, I would like to quantify the amount of nitrogen incorporated into the soil via nitrogen fixation. This could be done using the N15 natural abundance method. I would also like to determine the optimum rate and type of nitrogen-based fertilisers that support both white clover performance and productivity, as well as profitability in Tasmanian dairy production systems. And finally, I would like to relate white clover directly to milk production in Tasmania. And finally, my acknowledgements. I couldn't have done it without any of these people. So Beth and Rowan, my supervisors, Leslie and Nathan, which helped with sample collection in the north of the state, the A.W. Howard Memorial Trust, which gave significant financial assistance to soil testing and travelling, all the staff of UTAS and my friends and family, and finally the Tasmanian dairy farmers that participated in my research. So thank you.
Thanks, Will. Has anybody got any questions?
Yep.
So Dougal has asked if you could, is that okay? Yeah. I just need to repeat for the guys that were listening online. Got some messages saying, please repeat the questions. So Dougal's asking whether Will can give us a sneak peek of some of his results from his surveys.
So the biggest one was that farmers are well and truly aware of white clover composition in their pastures is below the desired level, and on average they indicated that they would like to see white clover up to about 30% in their pastures. At the moment it's well below, as you can see from my studies. Other things including fertiliser use and bits and pieces like that, it was hard to actually get concrete answers because of the variation. A lot of the farmers use soil testing on a biannual sort of basis, and therefore fertiliser use ranges from year to year. And in terms of like irrigation and stuff like that, that also varied across farms and regions based on mean rainfall and things like that. So to summarise, it's a pretty hard thing to pinpoint exact management practices that are having a significant effect on white clover. Yeah.
I was wondering, I've got the privilege of being here for 1 second. Could you just give some comment about how accurate, whether they're high and low paddocks, were they always, was the high paddock always higher than the low paddock?
Yeah, that was another thing. So when we went out to the farms and you'd ask a farmer, is this, like, can you give us a high and low paddock? And they'd assign us 2 paddocks. We'd go out and find that the high paddock would often be a lower composition when compared with the next paddock, so it made it a bit tricky in that regard as well, because some producers didn't quite have a firm grasp on how much clover was actually in their paddocks. So, yeah.
Awesome. Sorry, Sergey. So, that's a hard question to formulate. So Sergey is trying to ask whether the negative correlation between nodule score and ammonia and nitrate is to do with residual. So whether the nitrate and ammonium is coming from the plant or whether it's coming from fertilisers.
Yeah. So based on my findings, because white clover as a whole within the state are poorly nodulated, I would suggest that the nitrate is coming largely from fertilisers over the plants. Yeah, is my answer.
So what Kathy's asking is, what are the barriers for producers to increase their clover composition, and are there some extension activities that might need to occur in order to help them to do that?
So I think the largest restrictive factor is money. So obviously at the moment farmers are making X amount off their pastures. If they're trying to move from a composition of white clover that's at about 5% to 30%, based on my findings, a reduction in fertiliser use will also result in a reduction in pasture productivity and therefore a lesser milk output and then a reduction in financial gains until such point where clover reaches a higher composition and then it can contribute to the pasture productivity and get back to a standard that were before.
Awesome. Okay, thanks very much, Will.
Thank you.